Yeah. So the next topic is design of synchronous up-down counters. So there is the up-down counter. So we'll see the design of the up-down counters. Okay. So up-down counters has this function here. So we'll have a control input called as up and down. Okay, control input called as up and down bar. So when this input is equal to 1, it will the count will be incremented. The count will be incremented by 1. Okay, so when this input is equal to 0, the count will be decremented by 1. Getting the point here?
Yes, sir.
Okay, so up down counter. So where if this control input will be having an input called as up and down here. If this is equal to 0, we'll be decrementing the count by 1. So whatever the present states we have, we'll subtract 1 from that, so that we'll get the count of that specific next state here. Okay, suppose if we are in the 6, present state is 6. So if up input is equal to 0, up and down input is equal to 0, the meaning of this is we have to go for a down counting here. So I have to subtract 1 from this. So when I subtract 1 from this, I'll get output of next state of 101 here. Okay, if this is equal to 1, so what I'll get here? So I'll get a count of 111. Okay. Clear. So this is what we see in an up down counter here. Okay, so up down counter, so we'll take the values from we'll take 3 values here. Okay, so this is present state. Okay, and here input is up and down bar here. So we'll take the values from 0, 0, 0 to 4 ones here. Okay, so QC, QB and QA. So 1 will be the input here. Okay, so the first one will be the input and remaining 3 are the present states here. Okay, remaining 3 are the present states. So first 8 will be the 0 inputs. Okay, so next 8 will be the 1 inputs. Okay, so this is up counting. So this is down counting. So when input is equal to 0, we'll perform the down counting. When input is equal to 1, we'll perform the up counting. So up counting in the sense, so plus 1 to the present state. Okay, plus 1 to the present state is nothing but the up counting, and minus 1 to the present state is nothing but the down counting. Clear?
Yes, sir.
Yes, sir.
Okay, so now we'll take the values from 0, 0. I mean, here it will be the input, and we'll be having 3 present states here. So we'll get 16. I mean, the combinations will be like 1, 1, 1, 1, and the first one will be the input here. Okay, so always we'll include the input with present states, so that will give you the number of possible combinations. Yes or no? So when we have the AB as the present state, and if input is equal to X, so we have the combination from 0, 0, 0 to 111, and we have AB as inputs, and we have AB as present states, and if we have XY as inputs, we'll get combinations from 0, 0, 0, 0 to 1, 1, 1, 1, and we have 3 present states here: QC, QB, and QA. Okay, and we'll be having 1 input, that is up and down bar here. So the 4 combinations will give a combination from 0, 0, 0, 0 to 1, 1, 1, 1. Okay, so that is the initial step we have to do. Now we have to decide whether it is a up counting or whether it is a down counting. Okay, so we have to decide whether it is a up counting or it's a down counting here. Okay, so what I said, so when up and down bar is equal to 1, so we'll perform the up counting. Okay, I'm up counting in the sense, so plus 1 to the present state here. Okay, so when it is like so down counting, so when this up and down bar is equal to 1 here, so 0 here, so we'll get a down counting, so minus 1 to the present state here. Okay, so check here, the first 8 are down counting because this is equal to 0. So if this is 0, so this is the present state here, so I should perform minus 1 here. Okay, so 0 minus 1 and it is a maximum list of possible is 1 here. Okay, so if I perform minus 1, I'll get a previous state, last state here. Okay, so the counting will be this one here. Okay, so generally 2's complement చేసినా కూడా ఏమొస్తుంది అంటే -1 చేస్తే ఏమవుతుందంటే I'll get a value of 111. Okay, if I perform -1, I'll get a value of 111. So 0 - 1. Okay, if I take the 2's complement of this one, so I'll get a 111 generally. Okay, if you want, you can check. Or else in other simple cases like, so we'll be having count from 0 to 7 here. So 1 2 3 4 5 6 7. So down counting is nothing but the previous state. So this is the previous state here. Okay, so again the previous states will be like this. So 0. Okay, so 0 previous state is 7. Okay, and next 1's previous state is 0, 2's previous state is 1, 3's previous state is 2, 4's previous state is 3, 5's previous state is this, 6's previous state is this, and 7 previous state is 6 here. So this is how we'll get here. Okay, so 7 0 - 1, I'll get a value of 111. Okay, so 0 0 1, I'll get a value of 0. So because this is a down counting, 0 1 0, I'll get a value of 0 0 1. So getting my point here.
Yeah, sir.
Yes, sir.
So do all this. So 0 down counting. So it's 111. So 1 1 1. Okay, and 0 0 1. So the next state will be equal to 0 0 0. Okay, and 0 1 0. The next state will be 0 0 1. Because it is down counting. 0 1 0 0 1 1 1 0 0 1 0 1, and this is 1 1 0. So this is down counting. So this is all we'll do with the down counting, and next values, up and down values, will be equal to 1 here. So we have to add 1 here. Okay, so we have to add 1 to this down counting. Okay, sorry, up counting. So up counting in the sense 0 means, so we'll get a value of 0 0 1. Okay, so 1 means 0 1 0. So 2 means +1 +1. So 3 4 4 5. Okay, so after 5 it's 6. So 1 1 0. Okay, and for 6 it's 7. So 1 1 1. But 7 it is +1 ante manaku 1 is the 000 vastundi. So we'll discard that 1. So I'll get a 1. Okay, so I'll get a 0 0 0 there. Okay, so the last state here. So this is down counting. Okay, so the first 8 when up and down bar is equal to 0, so that is down counting. Will perform down counting. So down counting is nothing but the present state -1. So up counting is nothing but the present state +1 here. Okay, so you have to be careful with the first one and last one. Okay, the first counts and the last counts here. Clear?
Yeah, sir.
So now what we have to do here is we have to take the, we have to determine the flip-flop inputs, because we have to draw the diagram. We have to find the flip-flop inputs. The flip-flop inputs based on the excitation table of T flip-flop. So we are designing this with the help of T flip-flop. We'll check the present state and the next state. So we'll check the present state and next state. We'll check the present state and next state. So this present state and next state will give the value of TC here. So this QB and QB +1 will give the value of TB, and QA and QA +1 will give the value of TA here. Okay, so that is what we have to do here. Yeah. So check here. So TC. So here the present state is 0. Next state is equal to 1. So what is when present state is 0, next state is 1? What is the excitation table? What is the input of T flip-flop? What will be the T flip-flop excitation table? Japan T flip-flop. So tell me the excitation table. It is 0 0 0 1. So 1 0 1 1. So what is the value of T here? So this is Q plus Q of T +1. Okay, so 0 0 అయితే ఏమవుతుంది ఇక్కడ?
0.
So when it is normal state, T is 0. Complement అయితే 1. Complement అయితే 1. Now ఈ same state అయితే
0.
Okay, so here also So here also,
One.
so here it is a
One
0
one
to
two.
1. It's, yeah. So next 0 to 0, it's a 0. 0 to 0, 0, it's a 0. Okay, 0 to 0. So compare these two. You have to compare this values and this value. So this is q of c and q of c plus 1. So 1 0 1 1 1 0. Okay, so 1 1, what is that? So 1 1
Zero, sir.
0. Okay, next one is 1 1, it's a 0. 0 0 0 0 0 0 0 1 1. Correct, na? Sorry,
Zero,
it's
sir.
0 0. It's a 0. Okay, so 0 1 1 0 0 0 1.
Yes, sir.
Yeah, so this is the TC. Next coming the T. And okay, so 0 0 1, it's a 1. 0 0 0. So 1 0 1. So 1 1 0. Okay. 0 1 1 0 0 0 1 0 1. So 1 1 0 0 0 0 0 1 1. So 1 1 0 and 1 0 1 0 0 0 1. So 1 1 0. So 1 0 1. Mistake there. So mistakes na ikkada.
No, sir.
Okay. So next TA. So TA take this one and this value. Okay. So 0 1 1 1 0 1 0 1 1 1 1 0 1 1. So we'll get all those. Okay. So we'll get all those with TA. We'll get all. Okay. So TA is equal to 1. Okay.
Yes, sir.
This is the value of TC, this is the value of EB. Okay, so now what we have to do, we have to we have to derive the equations for K maps here. I mean, we have to find the K maps for this equations here. So already we have TA is equal to 1. 1 minute. Yeah. So we need the K maps for this. right? So we'll start with TA. So TA value is all ones. So we have all ones here. When it is all ones, so TA is equal to, okay, this value will be equal to, so this is up down, so I'll call it as UD. Okay, so wait, I'll take this as UD, and so UD stands for up down here, and QC. So UD QC on one side, and QB and QA on other side. Okay, so it's like 0 0 0 1, so 1 0 1 1 0 0 0 1, so 1 0 1. So TA is equal to 1 here, because we'll have all the groupings here. We'll get a 1. Okay, clear. So next we'll go for the next value. So TB value. So 1 0 1 0 1 0 1 0. Yellow to yellow. Okay, so we'll get the values of this one. Okay, so 1 0 1 0 1 0, 6 values, right? So this is 1 0 1 0. Okay, so 1 0. So this is a 0 here. Okay, so 6 values. These are the 6 values. So 1 0 1 0 1 0, 6 values. Next, 1 0 0 1. Okay, here it is 1 0. This is 0. This is 1. So I'm just noting that you have to be perfect with these values. This is 0 1 2 3. Okay, so these values are 0 1 2 3, and this is 4 5 6 7 8 9 10 11 12 13 14 15. Okay, so that will be perfect with that. Okay, so I think you all know those things, right?
Yes,
Okay,
sir.
yeah.
Yeah, sir.
And so this is, so where did we stop here? So this one, and we have we stopped at 0 1 2 3 4 5 6 7 8 9. So 9 the stop the sum. So after 9 it's 10. So 10 is 0, 11 1, 12 0, 13 1, 14 0, 15 1. Okay, so it's like 11 9 10 0, 11 1, so this is 11, 12 0, 13 1, next 14 0, 15 1. Okay, so this is for TB. So this is for what we get for TB here. So this is okay, so this is U and QC, QB, QA. Okay, so this one can be formed as a quad here. Okay, so the 0 0 0 1, so 1 0 1 1, and this is 0 0 0 1, so 1 0 1 1. So this is a quad, and we can form another quad here. So what is that another quad? So this two, so this two and this two. Yes or no?
Yes, sir.
Okay, so what is this quad? This is, what is the value we'll get? We are getting here. So Q of, sorry, this TB is equal to, so this value. So what is this value? So this value is, so what is the row here? So row term is like, so addition of this one and this one. So this one and this one will give value of UD. Okay, So this one will give a value of UD, and adding this row into column. So column this value and this adding this column will give a value of QA.
QA.
Okay, so UD QA. Okay, and so these two. So this two rows here. So rows. So rows. This adding this one and this one will give a value of U bar D bar. Okay, so UD bar. Okay, because this is this column and this column. I mean this rows in the sense addition of these two. So columns, where to check these two columns here. Okay, so 0 0 and 1 0. So 0 0 and 1 0 will eliminate the value of QB. It's QA bar. Yes or no?
Yeah, sir.
Yes.
Okay, so TB is equal to UD QA plus UD bar QA bar. Okay, so that is the value of TB. Okay, so that is the value of TB here. Right. Right, we'll write it in the last. So because it's difficult to write now. Okay, so last one is we have to find the value of TC. Okay, so this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, problem with this. Okay, so the ones are from 0 is 1. Okay, so 4 is 1, 0, 4, 11. Okay, so 0, 4, 11. Afterwards 11, 12,
15,
13,
sir.
15. 0, 4, 11, 15. Okay, so the values are, this is 0, this is 4, and this is 11, and this is 15. So only we'll get two pairs here. So this pair and this pair. Okay, so this is QB QA. This is UD QC. Okay, so this is 0 0 0 1, so 1 0 1 1. So 1 0 1 1 0 1, and this is 0 0. Okay, so what is this pair here? So what is the row term is nothing but, so what is the row term? So row term is, so 1 1
QD, sir.
1 0. So 1 1 plus 1 0 is nothing but, so UD. Okay, so we don't have C term here, and this row here, this complete column. So what is the column here? So QB QA. Yes or no? Okay. Coming to this one, so these rows here, so 0 0 0 1. So we'll get a value of UD bar. Okay, so into this
QB bar.
column, the column is
QA
like
bar.
QB bar, so QA bar. So this is the value of TC. Okay, this will be the value of TC.
Yes, sir.
So this is a way we follow up down quanta we wave for. Now we have to draw the diagram. Okay, now we have to draw the diagram for this one. We have to draw the diagram for the flip flop here. Uh, so equations are like this. So T A is equal to 1. So T B is equal to UD bar QA bar plus UD QA. Okay, and TC is equal to UD bar QB bar QA bar plus UD QB QA. So these are the equations we got here. Okay, so this is this TA. Three flip flops are required here: TA, TB, and TC. Okay, so why three flip flops? I mean, we have seen the flip flop inputs, right? So we need three flip flops there. So TA, TB, and TC. So this will be right. We have to draw the diagram here. Okay, so this is TA. So TA is 1. Okay, so there being a common clock here. The clock is given. Okay, this is TA and this is QA and this is QA bar. This is QB bar, and this will be TB. Okay, and this is TC and QC bar. Okay, so TA is equal to A, fine, and we need an up down value here, so up down counter. So this will be equal to, we'll mention that here. So this is clock stop. Okay, I'm rubbing this. Just note that values. We already else into the. So stop down bar. Okay. So one is the normal value, other one is the inversion value. Okay, so we'll check whichever it is needed. So what is the value of TA is 1, fine. So TB is equal to, so TB is equal to UD bar QA bar plus UD QA. Okay, so what we need here is, so we need an OR gate. Okay, we need an OR gate here. Okay, so this is and we need two AND gates. Okay, so two AND gates are given to TB here. Okay, so what is this value? So we need UD bar QA. So UD is nothing but this one. So UD bar is nothing but this one. UD bar into QA. Okay,
Yes,
so
sir.
UD bar in QA, and what is this value? So UD QA. So we need a UD value and QA value. So this value is so just a space. So we want this one connection now. So just this value. This is UD and UG bar and QA bar, right? So this is not this one. So wait a minute. So this is UD bar and QA bar, okay, and there is a UD and QA, okay. So this is TV, yes or no? So check
Yeah,
these
sir.
values, UD and QA plus UD bar and QA bar. These two are added here. Next we'll go for TC. Okay, so we'll be having a TC value here. The TC value will be, so what is the value of TC? Okay, so TC is equal to UD QB QA, UD bar QB bar QA bar. Okay, so you get a UD QA. Okay, so what is this value? So what is this value here? So we need here also. So here also we need an OR gate. Okay, and two AND gates. And here also we need two AND gates here. Okay, so one AND gate should be, so this value UD bar QA bar, sorry, QB and QA bar and QB bar. So other AND gate output should be equal to, so UD QA QB. Yes or no?
Yes, sir.
సో ఇదే కదా మనకి వచ్చింది. ఓకే, సో ఈ AND gate కి ఎక్కడి నుంచి రావాలి మనకు? UD bar, we have QB here, so that's fine. So we can have so this is QB bar. Okay, so we have QB bar here. Other thing is QB bar and QA. Okay, so what is this? So what is this value here? So what is this AND gate output? ఈ AND gate output ఏం చెప్పండి? What is the output of this AND gate? ఈ AND gate output ఏంటి? Hello. What is the output of this AND gate and what is the output of this AND gate?
UD bar, QA bar.
Yeah, this is UD bar. Okay, so this is UD bar and this is QA bar. So this is equal to, so UD bar QA bar, right? And this output, so will be equal to one of these AND gates here. Yeah. Okay, so take this gate here, draw this. So this output is given as input to this one here. Any doubts here?
No, sir.
Okay, and here what is
No,
this
sir.
output here? So this output is UD
UD, QA. QA.
QA, and this is given to this AND gate. Okay, so this output is given to this gate, and we have QB here. So QB is given to this AND gate. Clear?
Yeah, sir.
Clear? Send doubts ne cheppandi, please
Yeah, sir.
So
Clear,
if there are
sir.
any doubts, I'll stop. I mean, here. Okay. So
No, no,
this
sir.
doubts, sir.
the up-down, okay, synchronous up-down counter diagram. So that is the design of synchronous up-down counter. Okay. So take the and so we are done with this up-down counter, Johnson counter, ring counter, a modulus counter. So what we have seen in the last class. So these kind of counters are called as synchronous counters. Now we'll discuss about resistors and shift resistors. Okay. So we'll discuss what is a resistor and what is a shift resistor here. Okay. So wait a minute. Okay, so last class we discussed about, I mean, in the previous classes we discussed about flip flops. Okay, so flip flops are the memory elements. Okay, so these flip flops are used to store the 1 bit of data. Okay, so they are used to store the 1 bit of data here. Okay, and so coming to flip flops here, so the circuits, the flip flops are combined. I mean, the flip flops are used in the circuits. So which will give rise to two kinds of circuits called as the resistors and the counters here. Okay, the circuits where the resistors and additional gates are used, and those flip flops and combination of gates will produce some kind of functions there. Okay, so this they can be classified into resistors and counters here. Okay, so we have few circuits that includes flip flops and usually classified by the function they perform. Two such circuits are called as resistors and counters. Okay, so resistors is nothing but group of flip flops. Is nothing but a group of flip flops to store the data. Okay, if it is an n-bit resistor, so we'll be having n flip flops. Okay, to store n-bit data. Okay, and counter, already we discussed about the counters now, so it goes to the predetermined set of states here. Okay, so predefined set of states, okay, I mean the states will be transferred from one state to the another state. On application of clock pulse, it will go to the predetermined set of states here. Okay, so the flip flops are essential circuits in the, I mean the flip flops are the main essential things in the memory elements. Okay, and these flip flops, so included with another gates, so they can be classified into two categories here. Okay, so the circuits which includes the flip flops can be classified into two categories here. So one is resistor one, other one is the counters one here. Okay, so resistor, n-bit resistor consists of group of n flip flop and capable of storing n bits of binary information. Okay, so if it is a 4-bit flip flop, so 4-bit resistor, so it will store the 4-bit data and it will be having 4 flip flops here. It will be having 4 flip flops. Okay, and I'll be doing some controlling operations. The controlling operations can be done. Okay, so when we include some gates there. Okay, so when few gates are included, so we can do the controlling operations. Clear?
Yeah, sir.
Okay, and so coming to the counters here, so counters are nothing but, so they'll go to the predefined set of sequences. They'll go to the predefined set of sequences here. Already we discussed here. So binary counter, so I mean if it is a BCD counter, it will go from 000 to 000 to 1001, and after 1001 it will again start from 0 here. So it will predefined on application of clock pulse. It will go from 0 to 1. From 1 it will go for 2. From 2 it will go for 3. It is used to count the number of clock pulses. Okay, it is also used to count the number of clock pulses here. Okay, so that is a function of the counter there. Okay, so in broadest definition, so if I want to define a resistor in a broadest way, okay, so it consists, a resistor consists of flip flops and gates that affect their transition. So we'll be using the flip flops for storing the data, for storing the binary information, and controlling that loading of data or transfer of data is done with the help of logic gates here. Is done with the help of the logic gates. You can see here, so the flip flops hold the binary information. The gate determines how the information is transferred into the resistors. Okay, so the I mean the way how the information is transferred is determined by the gates here. Okay, so register is a combination of flip flops, okay, plus logic gates. Okay, so what is the function of flip flops? To store binary information. It is used to hold the binary information, and gates is used to control the transfer of information. Okay, used to control the transfer of information. The way it is transferred is decided by the gates that we are using. Clear?
Yes, sir.
Okay, so in the earlier example, we have seen that up down, so up and down is controlling the transfer of information. How the data is transferred is decided by the logic gates here. Okay, so that is a register. So register is a combination of, okay, a register contains flip flops to store the binary information, and gates that affect the transition. So the gates will control the transfer of information into the register. Okay, and counters are also a special type of register. A counter goes to the predetermined sequence of states. So already the states are determined. If I say that it is a BCD counter, the BCD counter will start from 00002, it will end with a 1001, and after 1001 it will again start from 0000. Okay, so that is what the function of the that is the function of the this one. That is a function of the counter here. So counter is a special kind of register. Okay, so counter is a special kind of register, so which will go through the predetermined sequence of states here. Okay, so which will go through the predetermined sequence of states. Okay, so a register consists of flip flops and gates here. Flip flops for storing the information, okay, and gates for controlling the transfer of information into the registers. In simple, we can say that register is a group of flip flops. Okay, if it is n registers, it will have n flip flops. It contains n flip flops there. Clear?
Yes, sir.
Okay, yeah. So next, you will see an example of a register here. Okay, so this show is the register which is constructed, a 4-bit register which is constructed with the 4 D flip flops. Okay, you can see this is one D flip flop, another D flip flop, third D flip flop, and 4 D flip flop. Okay, so and these D flip flops are given 4 inputs here: I0, I1, I2, and I3. Okay, they are given a common clock, and the outputs are A0, A1, A2, and A3 here. Okay, so when we apply the clock, it triggers all the flip flops on the positive edge of the pulse. So because it is not negative edge, because there is no bubble here, it will trigger. So the triggers means it will change the state of the flip flop here. It will change the state of the flip flop on the positive edge of the pulse here. So this is positive edge. Like this is the positive edge. So it will change the state of the circuit. So on the positive edge of the pulse here. Okay, and we have reset here. So reset is used to clear all the contents of all the flip flops at a time here. Okay, so initial state should be like, if reset is applied, it will clear all the values of the flip flops here. All the values in the sense, you will get A3, A2, A1, A0 as 0000. Okay, so reset, or it is also called as clear here. Okay, so it is used to store the 4-bit information. Okay, so it is used to store the 4-bit binary information. Yes or no?
Yeah, sir.
Okay, so 4-bit information. Register is a group of flip flops. So we have 4 flip flops here. It will use to store the 4-bit data here. We will be having 4 inputs which are loaded parallelly, and we will be having a reset input which is used to reset the flip flops here. So that is the case here. Okay, so there is a general intro here. Okay, and registers with parallel load. Okay, so what we had to do here is we had to load all the registers. Okay, so parallelly. So parallel in the sense, we had to load this I0, I1, I2, and I3. Okay, into D flip flops. Okay, so with the help of load input. Okay, so with the help of the output here. Okay, so
Yes, sir.
actually, in the earlier case, what we have seen here. Okay, so here clock is controlling the function of the registers here. When I am giving the clock signal, So when giving the clock signal on the positive edge of the pulse, so we are loading the data into the D flip-flops. Okay, so the meaning of this is the clocks are controlling the function of resistors here. Okay, the clocks are controlling the functioning of the resistors, but it's better we have to make sure that the input D is controlling the loading of the inputs. Okay, clocks will be there, but instead of clocks controlling the resistors here, we should make sure that the inputs are controlling the, I mean, the D input is controlling the function, I mean, loading of the data here. Okay, so here you can see the clocks are given all at once. When the clocks are activated, when the clocks are activated, when the clock triggers all the flip-flops on the positive edge of the pulse. Okay, so after triggering this flip-flop, the data will be received by the flip-flops here. So here clock is controlling this resistors here. Okay, so we have to avoid this. So for avoiding this, so what we have to do, so we'll use a load signal here. Okay, we'll use a load signal. So the load signal is applied, the load input is applied to the applied, I mean, directed from the gates into the D flip-flops, so which will controlling the loading and unloading of this data here. Okay, you can see this diagram here. So what is the definition I told you already? So the resistor is nothing but consists of a group of flip-flops. What are the function of group of flip-flops? It is used to store the binary information, and the logic gates which will control the transfer of information into the resistors. Okay, so here we are not using any kind of resist, I mean, gates here. They are not controlling the operation of this resistor. Only the clock is controlling the operation of these resistors. Okay, so for if we want to avoid this, I'll be using some logic gates here. So those logic gates will control the loading of information into the resistors here. Okay, so here I'm using a load input here. You can check here. Okay, so load input, and I'm using some logic gates here. So this load input will determine this I naught should be loaded into this flip flop or not. Okay, so load input 1 aithe load cheyali, load input 0 aithe load cheyakuddu. Load cheyakuddu in the sense, so what is that I want here? So I naught should be the input. Okay, so I naught should be the output of this AND gates here. When load is equal to 1, so I should get I naught here, I should get I1, I should get I2. Okay, I should get I3. Okay, so that is what I had to get here. Okay, so if load is equal to 0, if load is equal to 0, it should retain the previous values. So the output is equal to A naught, and it should have A1, A2 and A3. So I should get the previous values only. Are getting my point here? Are you clear here? So please understand
Yes,
this.
sir.
A resistor is nothing but a combination of flip-flops and the logic gates here. Flip-flops for storing the binary information. Okay, so flip-flops for storing the binary information, and this one resistor, I mean, gates for controlling the transfer of information. So in the earlier example, so what we have seen, that the clock is controlling the transfer of information into the resistors. So that should be avoided. So that is avoided with the help of the load signal and a few logic gates here. So when the load is equal to 1, so it should load the data, input data into the flip-flops here. If load is equal to 0, it should retain the previous values. It should retain the previous values like A0, A1, A2 and A3, or should be retained here. Clear?
Yeah, sir.
Okay, so you can check here when load is equal to 1. So when load is equal to 1, so I'm using an inverter here. So this is equal to 0, and this is A0 here. Okay, so 0 into anything. So what is 0 into anything with AND gate?
0, sir.
0. Okay, and here when load is equal to 0, and this is 0 and this is equal to 1, so this is 1 and I naught. Okay, so 1 into I naught is like I naught in case of AND gate here. Okay, and with OR gate, 0 plus I naught is I naught when load is equal to 1. Okay, yes or no?
Yeah, sir.
Yes, sir.
Yeah. And I1, so load is equal to 1 only. So load is equal to 1. So here it is a 0, and here it is A1. So 0 into A1 is 0, and I1 into, so this is 1 here, right? So this is I1. So I'll get an I1 here. In a similar way, I'll get an I2. In a similar way, I'll get an I3. And the outputs are nothing but, so I0, I1, I2, and I3. I'm loading the value when load input is equal to 1. Clear?
Okay, sir.
Yes, sir.
Okay. Load is equal to 0. When load is equal to 0, this will be equal to 1, and again this will be equal to 0. So this is 1 into A naught, and here I'll get a 0 into I naught. Okay, I'll get a naught here. Okay, so A naught and here 0, so I'll get a naught, and here A1, so here A2, and here A3. So I'll be retaining the previous values only, I naught, A naught, A1, A2, and A3 when load is equal to 0. Okay, so this is the resistor with parallel load, so we are controlling the informations like this. So when this is equal to, so when load is equal to 0, so will not perform any loading, it will retain the previous values. When load is equal to 1, so this will load the new data, this will load the out, the new outputs will be, I mean, the new outputs will get the new outputs here. So when load is equal to 1. Okay, so here these are the logic gates which is controlling the transfer of information into the flip-flops here, and these flip-flops are storing the information, they are not controlling the information, but resistors are, these gates are controlling the information here. Yes or no?
Yeah, sir.
Okay, so this is resistors with parallel load here. Okay, and coming to another kind of resistor, it is a shift resistor. Okay, so we'll be having a resistors, so which are capable of shifting the data to the right or left. Okay, so I'll say like this. So 1011 is the input data. Okay, so at the next clock pulse, it has to shift the data in the sense, so it has to shift the data to the right antenna. So this will be moved like this. Okay, so ఇది ఇక్కడికి వెళ్ళాలి, ఇది ఇక్కడికి వెళ్ళాలి, ఇది ఇక్కడికి వెళ్ళాలి, ఇది డిస్కార్డ్ అవ్వాలి అంటే ఏం చెప్తానంటే ఇక్కడ 0 ఇన్సర్ట్ చేయాలనుకుందాం. Okay, so 0101, so the last value is discarded here. I'm transferring the data serially here. Okay, transferring the data serially. Okay, so data is shifting serially here. So serial in the sense one by one, and parallel in the sense all the bits at a time. Okay, there are two kinds of transfers here, so serial transfer and parallel transfer. In serial transfer, so one by one bit is transmitted to the left or right. Okay, so here shift resistors which are capable of shifting the data by one bit position here. Okay, so there we can shift the data to the right or to the left. Clear?
Yes, sir.
Okay, so shift registers అనేది ఒక కాన్సెప్ట్ ఏం చేస్తుంది అంటే it will perform the shift of data. How it will perform shift of data? It will perform shift right operation or shift left operation. Okay, or it can perform both also. Okay, so those kind of operations are performed with the shift registers. So this is one of the example here. Okay, this is one of the examples. So I'm giving the serial input here. Okay, so I'm giving the serial input, and this will be the serial output. And if, for example, if I take these values like this, so 1 0 1 0 అనుకుందాం. Okay, and here 0 అనుకుందాం. Okay, so for application of clock pulse, so what happens here is, so this will be shifted to this is shifted to this shifted to this, and this shifted to this one. Okay, so so the value of first output will be equal to 0, and this will becomes 1, and this will become 0 again, and the serial output will become 1 here. Clear?
Yes, sir.
Yes, sir.
Yes, sir.
Data is shifted to the right here by one bit position on application of the clock pulse. So for one clock pulse, data is shifted by one bit position. For two clock pulses, data is shifted by 2 bit positions. So this is how it happens here. Okay,
Yeah, sir.
Yeah, sir.
yeah, so this is a shift register. Okay, each clock pulse shifts the contents of the resistor one bit position to the right. So in this above example. Okay, so serial input determines what goes to the leftmost flip flop during the shift. So generally we'll take it as a 0 here. The serial output is taken from the output of the rightmost flip flop here. So what are the rightmost flip flop? So that will be taking the output here. From that we'll take the output, and whatever the leftmost, so will receive the serial input. So serial input, if I decide it as 0, it will be 0. If I decide it as 1, it will be 1. Okay, So rightmost will receive the serial output, will take the serial output from the rightmost flip-flop, and leftmost flip-flop will receive the serial input there. Okay, so that is the case here. Okay, and next we'll see the serial transfer here. So generally digital systems will be using the transfer of information. There will be transfer of data. So transfer of information can be done in two ways here, so serial way and the parallel way. Okay, I'll explain the serial transfer and parallel transfer here. Okay, so serial transfer, if there is a sender, okay, if there is a sender and receiver, okay, so I'll be having this data, so 1011, so this is sender and this is receiver. Okay, serial transfer ఎలా ఉంటుంది అంటే, so transfer this bit first. Okay, so I'll transfer this for first clock pulse, this bit will be transmitted here. Okay, so 0 will be transmitted. For the second clock pulse, this will be transmitted here and this will be shifted to this position. Okay, for the third clock pulse, okay, so for the third clock pulse, so this is moved to this place here, so 0 1 0. Okay, so the second okay, and this is second, this is the third clock pulse. For the fourth clock pulse, so one is shifted to this one here. Okay, so it will have 4 clock pulses to transmit the data from sender to the receiver. I mean, we are transmitting the data bit by bit here, so we are only transmitting one bit at a time here. Okay, so one bit at a time, the data is transmitted one bit at a time here. So clear? So that is serial
Yes, sir.
transfer. Okay, for the parallel transfer, all the bits are transmitted at a time here. So this is 1011, and the bits, all the bits will be transmitted at the same time. For a single clock pulse, will transmit all the bits at a time. Okay, so parallel transfer may be fast, but it's not reliable. For example, నేను sender to receiver ఉంది ఇక్కడ, నేను 4 lines యూజ్ చేయాలి. I mean, I should use 4 bytes. Okay, so transmit information from sender to receiver. So 1011, 4 bytes use చేయాలి. If I get an error here, so I have to check all the 4 bytes here. So we have to find fault with all the 4 bytes. So 4 bytes లో ఎక్కడ మనకి ఎర్రర్ ఉందో చెక్ చేసుకోవాలి. Okay, so whereas in case of serial communication, okay, so serial communication, so I'll be transmitting only bit by bit here. I'll be using only a single line for the transmission here. Okay, so when there is error, I can find it easily. So when there is an error here, I can find it easily. Okay, so in the case of the serial transfer, so serial transfer is a bit by bit transmission, and parallel transfer is a all the bits are transmitted at the same time here. Clear?
Yes, sir.
Yeah, sir.
Okay, so that is with the case of serial and parallel transfer. Okay, so this is one kind of a serial transfer. Okay, this is one kind of a serial transfer circuit here. Okay, so we can check that. Right, so here we'll take a shift register, so we'll just check the operations here. So generally, if I take this as a shift register yellow 1011 ఉంది అనుకుందాము. Okay, so this is the initial value of this register. Okay, and this register will be having values of 0000 అనుకుందాం. Okay, so applying the clock signal here. When the clock signal is applied, okay, clock signal is applied, so the first bit is shifted to the SO is nothing but serial output here. Okay, so this one is given as serial input also. Okay, so this one is given as serial input. Okay, so you check this function here, so 1011 is the thing here and given as serial input to the shift register also. Okay, so this one is given as serial input and also to the shift register B. Okay, so the next value will be like this. So 1 is given here, so here 1, again we got a new value of 1 here. Okay, 0 1. Okay, and here I'll get a 1 0 0 0, and the serial output will be equal to 0 here. Clear? This is for the first clock pulse.
Okay, sir.
Okay, and second clock pulse. So again this value. So what is this value? So 1011 ఉంటుంది ఇక్కడ. Okay, so this is given as a serial output and also the serial input. Okay, the second output. So again I'll get a 1 1 1 0, because you know this serial output, what is the serial output here, will come here, will come as input here. So already we have 2 ones, another one will be a third one, and this will be shifted right here. Okay, so shifting will be done to the left here, sorry, right. Okay, so this is shifted to this is shifted to this is shifted to this, and this is given as input and also the output here. So the new value will be like, so here 1 1 0 0 for the second clock pulse. Yes or no? అర్థమైందా లేదా?
Yes, sir.
So please be clear here. Okay, so just shifting the values ante, shifting by 1 bit position, oka clock pulse ki oka bit shift avutundi. So 1011 undi, so ikkada entante manam loss of data avutundi in case of if I want to retain the initial value after 4 shifts, so data will be shifted to the shift register B. Okay, but ikkada unna data loss avutundi, so the loss avukunda this there is a feedback path here which is given, which is used to retain the initial value. Okay, so now we got 1100, so 1110, and if I perform again shift operation, clock pulse is applied. Okay, so this 0 is moved here, so this 0 is moved to the serial input and also the, okay, so and also the shift register B here. Okay, so what is the value I'll get here? I'll get a value of 0 111. Okay, so 0 111, and here if I move the value of 0 here, I'll get 0 110. Yes or no?
Yes, sir.
Okay, and the fourth clock pulse, so this should be given to the serial output and also the input here, and this one is given here. Okay, so this one is given here, so 1 is given here, so 1011, it is what I'll get in the shift register B, and here also 0 111, and this one is given here, so I'll get a 1011. Okay, so what happened here? After 4 clock pulses, the value of shift register A is shifted to shift register B, and shift register A is retaining the initial value. Clear?
Okay, sir.
Okay, so this is the kind of serial transfer. This is one example of the serial transfer. Okay, so if this is the value here, okay, if this is the value of shift register, the example what we have taken. Okay, shift register B, so shift register B is replaced with the shift register A value, and shift register A will retain the previous value. Okay, so this is one kind of example here. Okay, I have taken 0000, so but after 4 clock pulses, so it is replaced with 1011. Okay, and shift register A will retain the previous value. The example just earlier, so one discuss this in example now, so this is possible here. Okay,
Yes, sir.
clear? So any
Yeah,
doubts
sir.
in that?
No doubt, sir.
Okay. What we see here is, so we'll see one kind of register as universal shift register. So you can take this diagram, or I have sent the PPTs yesterday, so just observe this diagram. So here we'll be having a universal shift register which will perform 4 or 5 operations here. Okay, you can check the diagram, and multiplexers are used here. Okay, so multiplexers are used.
Okay, sir.
Okay, so this is the diagram. So which is called as universal shift register. Okay, and it will perform these four operations. Okay, it will perform the clear operation, which will clear the resistors to 0. Okay, and we'll be having a clock input to synchronize the operations. We'll perform the shift operations. Okay, and it will perform the shift left operation. So we'll be performing this operations here, and one operation is like parallel load here. We can load all the data at a time here. We can load all the data at the same time.
Okay, sir.
Okay, so these are the properties of this shift register. Okay, these are the properties of the shift register here. So we should perform the shift right operation, shift left operation, and clear operation, and parallel load operation. So we'll be taking the help of the multiplexers here in order to perform the universal shift operation. So parallel load will be done here. Okay, so it is capable of shifting the data left and right. So it is called a universal shift register. Okay, so if it is like shift, if it will shift the data to the right only. Sorry, I think the net connection has been dropped. So yeah. So universal shift register. So am I audible?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah, sir.
Okay. Yeah, universal shift register, which is capable of performing all those operations. You can check the multiplexer here. So multiplexer has 4 inputs. Okay, so we'll be using it 4:1 multiplexer. We'll be having 2 selection lines here. This selection line will decide what is the operation that has to be performed here. That is being performed. Okay, clear. Okay, so check what happens if S1 S0 is equal to 0 0.
Yes, sir.
Okay, yeah, so 0 0, it will select all the 0 inputs here. It will select all the 0 inputs of the multiplexers. You can check here. Okay, so this is a register here. So register will be having 4 flip-flops here, so which is called as a 4-bit register. It is a 4-bit universal shift register. So when selection lines is equal to 0 0, it will select all the 0 inputs. So what are the 0 inputs here? So what are the 0 inputs? It is equal to A0 is given, and here A1 is given, and A2 is given, and A3 is given. Okay, so what happens if S0, S1, S1, S0 is equal to 0 0? Okay, the outputs of each multiplexer is A3, A2, A1, and A0. So the meaning of this is it retains the previous value. It retains the previous value. There is no change in the register operation. Clear?
Yeah, sir.
Yes, sir.
Okay, and what happens if S1 S0 is equal to 0 1? Okay, so 0 1, so 0 1 aithe, so if it is like 1 0 1, so it will select all the 1 inputs here. So 1 inputs, check the 1 inputs here. So the 1 input is like A1, so I'll get A1 here, and here the 1 input is, this is A2, and here the 1 input is A3, and here the 1 input is serial input for shift right. Okay, so serial input for shift right operation. Okay, so coming to the shift right operation, if I take this A3, A2, A1, and A0, so if I shift right operation, it should be done like this. So serial input should be placed in A3. Okay, so A3 placed serial, okay, and A3 shifted to A2. So A3 ekkadaithe undo adi A2 place loki veltundi. A2 place lo get a, sorry, A3 place lo, A2 place lo I'll get a A3, and A1 place lo I'll get a A2. Fine. So A1 place to I get a A2, and A1 is shifted to A0 place. A1 is shifted to A0 place, and A0 is discarded here. Clear?
Yeah, sir.
Okay. So this is shift right operation. Data is shifted to the right here. Okay, so when it is equal to 0 1, data is shifted right here. Okay, when it is 1 0, so all the second inputs are selected. So check the second inputs here. So second inputs is serial input for the left shift operation. Okay, and second inputs, so I'll get a A0, and the second input I'll get a A1, and second input I'll get a A2. Okay, so coming to shift left operation, so if it is like A0, A1, A2, and A3, so the serial input is shifted to A0 here. It is replaced, A0 is replaced with serial input. Okay, and A1 is replaced with A0 value. Okay, and A2 is replaced with A1 value, and A3 is replaced with A2 value, and will be A3 will be discarded here. So we'll get A2, A1, A0, and Si. Clear? So this is shift left operation. Okay, so S1 S0 is 1 0 will perform the shift left operation. Okay, and if it is like 1 1, so all the third inputs. So third inputs, so I get a I0 here. Okay, and I1, so I2, and I3. Okay, so we'll perform the parallel load operation. We'll perform the parallel load operation when it is equal to 1 1. Clear?
Yeah, sir.
So this is the
Yes.
various functions here, and this is the operations that are performed here. So no change is the first one, shift right, a shift left, and parallel load here. So this is the universal shift register. Clear?
Yeah, sir.
Right. So we have seen this resistors and shift registers here. So next class we'll see about ripple counter. So just 1 hour of class, we'll finish that topic there. Okay. So ripple counters, and I'll explain the difference between the synchronous counters and the ripple counters. Okay. Just a small topic, the half hour to 45 minutes or 1 hour. Okay. That finishes the third unit, and we are left with one or two topics like చిన్న చిన్న ఉన్నాయి అవి కూడా కవర్ చేస్తాను వీలైతే. So this is your 4 units అయిపోతాయి రేపటితో. Okay, so you left fifth unit kuda, so just half of the unit, so remaining half is removed from your syllabus as it is becomes more complex. So this unit is removed. So this topic I'll tell in a general way, so it will take another 3 to 4 classes. So within 1 week, so we'll finish this and we'll start the problems which are not discussed in the classroom. So we'll discuss about the third and fourth units only. So third and fourth units, so in case of problems in there, we'll solve those problems there. Clear?
Yes, sir.
Yes, sir.
So yeah, drop your attendance and you can leave. So any doubts you can ask, and any questions?
No, sir.
Okay. Yeah, fine.